morning, students. This is Mr. Montes, and we have another lesson for you this week. We are going to be working. It seems like we're going to take like a little bit of a left turn from what we've been doing, but really, it has to do with some stuff that's going to come up on Wednesday. So we're going to leave solving quadratics, factoring quadratics for just a tiny bit, and then we're going to do this simplifying radicals thing, and then we're going to come back to solving quadratics on Wednesday. So first things first, what is a radical, right? So what the heck is it? I kind of had to toss that in there just for fun. So here's what a radical looks like. It's this symbol, and you might all recognize it as the square root symbol. But what it really is, it's a radical. In this case, we have multiple pieces. This symbol right here, let me see if I can grab my mouse and outline it. Where are you, mouse? There you are. This symbol right here is called the radical. This little number right here is called the index, and the index is very important because it's telling us what to do. And then this number in here is called the radicand. And then the whole entire thing is called the radical. Now, we have here, this 3 means cube root. Cube root. So it's the cube root of 27. So I guess something you might ask is, what is the cube root of 27? Right? So let's scroll down right here. Well, here's what it represents. This thing right here represents the number. Let's put a little question mark. Represents the number that when I multiply it to itself, when I have 3 factors multiplied, as in I cube it, I end up with 27. So we have to think about the cube root of 27. What is the cube root of 27? Well, what number do I multiply? Do I have 3 factors of, all multiplied, and it has to be the same number that gives me 27. Well, 3 times 3, there's 2 factors there, right there is 9. And if I multiply that by 3 again, that's 27. So the cube root of 27 is actually equal to 3. Right? So this is equal to, well, I probably shouldn't erase that. The cube root of 27 equals 3, because 3 to the power of 3 is equal to 27. Simple, right? Just a couple of rules. It has to be the same factor. That's the way it works. And if you don't see an index, if I erase that right there, we automatically assume that to be a 2. Okay, so we're actually going to jump into, let's put a line right there. We're actually just going to take a look at square roots. We're going to forget cube roots, fourth roots, fifth roots, all that stuff. So we're just going to stick to square roots because we're going to be working with what's called the quadratic formula on Wednesday. Okay, so let's just start off with a simple one, the square root of 4. Remember, if there's no number there, it's a 2. Okay, so let's think about, what is 4? What's the square root of 4? So remember, it represents the number that when I square it, I end up with 4. So what is that number? You might have already guessed it. The number is 2. 2 times 2 is 4. Right? Let's try another one. Let's try the square root of 16. Okay, remember, square root of 16 means the number such that when I square it, I end up with 16. What is that number? Well, if you do a little bit of work, it's not 2 times 2, it's not 3 times 3, but 4 times 4 works. So 4 squared is equal to 16. So this is equal to 2 over here, and this was equal to 4. Let's put a little semicolon there. Okay, let's just do one more. How about the square root of 81? Okay, so now we're thinking, what number to the power of 2 is equal to 81? Well, in this case, it's 9. So the square root of 81 is 9. All the numbers that I've given you so far are really, really nice. So there are numbers like, whoops, if I took the square root of 5, what number do I square to give me 5? And the interesting thing about this is this doesn't have a whole number solution. This number that would go right here, this would be an irrational number. And we're not actually going to get into that too much, but just know that not every square root that we're going to take a look at is going to simplify to be a whole number or even a rational number. Sometimes we get these things called irrational numbers. Irrational numbers are like pi, right? Pi is equal to 3.14 dot 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 dot, keeps going on and forever and ever and ever, never repeats, never terminates, right? So that's just a little basic overview of square roots. Now let's take a look at something like the square root of 50. Okay? And we're trying to figure out what number to the power of 2, gives me 50. Now here's the thing, this one doesn't actually work, right? 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. Ooh, that one's really close. But then 8 times 8 is 64. So this one doesn't simplify to be down a whole number. But there's this thing that we could do that's called simplifying a radical. And here's what we're going to do. And here's the rule that we're actually going to use. If I have the square root, my face isn't in the way, right? No, it's not. If I have the square root of a times b, that's multiplied together, there's a rule that says that I can separate that into two pieces, as in the square root of a times the square root of b. Now, what's that going to do for us? Well, that's going to allow us to simplify. Like, for example, if I had the square root of 4 times 6, it was written like that. The radical goes all the way over those 4 times 6. I can separate this into the square root of 4 times the square root of 6. And I would want to do that because I know what the square root of 4 is. The square root of 4 is 2. So this is 2 times the square root of 6. So this thing here can simplify into that thing there. And that's what we're actually going to be doing, right? But to do that, we actually have to work with what we call perfect square roots, perfect squares, right? And I'm going to drag this over real quick. Let me see. Hopefully it doesn't get all messed up here. If you look here on the right hand side, oops, it did. Let me scoot over. We have what we call perfect squares. So the square root of 1 is equal to 1. Square root of 4 is equal to 2. Square root of 9 is equal to 3. We've got square root of 16, 25, 36, 49, 64, all the way down to the square root of 900. Basically, just a bunch of perfect squares, right? So we're going to actually want to work with those perfect squares. And what we're going to want to do with those perfect squares, let me scoot this over to my other screen now. Come on. Come on. Technical difficulties. There we go. It's taking a little bit. Hold on. You know what? Let's just minimize that. Get that out of the way. Okay. So here's what we're gonna have to do. We can't do this right now. It's not gonna work out to what we want it to work out, which is a whole number. So what we're gonna do is we're gonna want to separate this into two factors. Is there two numbers that I can multiply together to give me 50, where one of them is a perfect square? Remember, the perfect squares that we have, where should I put them? Off to one side, right? We got 1. Well, we don't even care about 1. We got 4. We got 9. So that's 2, 3, 16. We got 25. We got 36. We got 49. We got 64. 81, 100, and I'll stop right there. Those are the perfect squares. So does one of these numbers over here, is that one of the factors of 50? And here's the thing, is when I look at 25, I can turn this into the square root of 25 times 2. Okay, so how does that benefit me? Well, I can utilize this rule over here, not just that part, but the whole thing. And I can separate this into the square root of 25 times the square root of 2. Now, what is the square root of 25? Well, that's simple. What number multiplied to itself gives me 25? That would be 5. So I end up with 5 times root 2, or I can just write it as 5 root 2. So this is the simplified version of that thing. And that's the goal for this week. That's what we want to do. This is the stuff that we want to work with. Okay, so let's try another example. Let's go with, we're going to say simplify the square root of 48. Let's change that. All right. So again, we're utilizing, and I'll do this in green. Remember, we're going to remember that the square root of a times b is equal to the square root of a times the square root of b. And we can utilize the numbers 4, 9, 16, 25. By the way, these are in the PowerPoint that's also provided, so you don't have to memorize them. 49, and you know what? We'll stop there since I already went beyond 48. So I have to think about, does one of these numbers divide 48? And there is, right? Actually, the simplest one would be 4, right? So 48, 4 is a factor of 48. In fact, I can rewrite this as 4 times, what would that be? 6, 1, 12? Is that right? Yeah, that's right. Okay, so now I can simplify. The square root of 4 times the square root of 12, and square root of 4 is 2, so that's 2 root 12. And you might think I'm done, but here's the thing. Can we simplify that even further? Well, it turns out that 4 divides 12. I can write 4 ends up being a factor of 12 as well. So we actually are not done. We have to continue simplifying. And I'll tell you what happened here in a second. This can be written as, again, 2 times the square root of 4 times 3. And then it's going to be 2 times the square root of 4 times the square root of 3. The square root of 4 is 2. So this ends up being 2 times 2 times the square root of 3, which is 4 root 3. So here's the thing. When you end up simplifying and you end up at the end, and like we did here, and you don't end up with the most simplified version, like 12, 4 still divides it, and 4 perfect square. It just means that there was a bigger perfect square that I could have used to divide 48, that I could have used with 48. So let me move this. Whoops. Let me move this over here. Let's get out of that. And in red, I'm going to do it again. Now, we know 4 is a factor of 48, but there must be a bigger number, right? And it turns out that that bigger number is 16. I can rewrite this as the square root of 16 times 3. All right, that means I can separate it into the square root of 4 times the square root of 3, not the square root of 4, that's square root of 16, which the answer is going to be 4 root 3. And we actually end up at the same spot. So even if you didn't notice that 16 was a factor of 48, and you did you did it this way like we did on the left-hand side, that's okay. It just takes you a little bit more work. And to be honest, a lot of times when I'm simplifying radicals and I'm working on some of this stuff, I end up having to do it twice because I don't realize that there's a bigger perfect square that divides it. So either way works. If you can see it this way, perfect. If you can see it this way, perfect as well. One thing to notice is notice that we had square root of 4, so 4 divided 12, right? But then 4 divided 48, then 4 divided 12. What's 4 times 4? It's 16, right? So 16 is just this interesting number that is made up of two perfect squares. So that's kind of what's going on here. Okay. In any case, that's about it. I think, did I have another example? Hold on. I think I did. Square root of 48, square root of 180. Yes, we got one more example. The square root of 180. Let's do that one. Okay, let's go again, simplify. I'll just do it one way this time too. I won't confuse you guys. The square root of 180. Okay, let's just list out our numbers that we're working with. We got 4, we got 9, we got 16, 25, 36, 49, 64, 81, and 100. All right, is there a number, one of these numbers here, that divides 180, that is a factor of 180? Let's see, 64, 100, no. No, you know what? I think the only one I can see right now is that guy. So I'm going to start off with that. Let's start off with 9. Okay, maybe we have to do a little bit more work, but that's okay. So let's just find a place to start. So what I'm going to do is I'm going to rewrite this square root of 180 into the square root of 9 times, oh, and I don't know what that is. But you know what you can do? Just use a calculator, right? So I'm going to write 180 divided by 9. So that's 20. So this is 20. 9 times 20 is 180. Maybe you already knew that. I didn't. That's okay. Okay, so if we continue on, we can split this up into the square root of 9 times the square root of 20. Square root of 9 is just 3, so I have 3 root 20. Now, are we done? We do have to check, right? So if I look at this 20 now, is there a number that divides 20? That's a factor of 20. And here's the thing, is that one is. So we didn't find the biggest perfect square, but that's okay. Just means we got to do a little extra work. So I'm going to do the same process again with 20 and 4 as I did with 9 and 20. So I'm going to write, maybe, should I do that? No, let's put an arrow right there. We're going to write 3 times the square root of 4 times 5. Where'd 5 come from? 20 divided by 4. We can split that up into 3 times the square root of 4 times the square root of 5. Square root of 4 is 2, so that's 3 times 2 times square root of 5. 3 times 2, easy to calculate, that's 6. 6 square root 5. And we are done. There's no perfect squares that divide 5, that are factors of 5. Now, here's the cool thing is I ended up with 6, right? 6 squared is 36. So I could have actually used that number at the very beginning. I just didn't see it. And that's okay if that happens. No worries. Sometimes we go a little bit, we take the long way just because that's the one we see first. Okay? So anyways, that's it. The PowerPoint has a few more, one more example. I'm not going to do it in this video. It's done for you. It's one that actually doesn't work. And I think it's I just said I wasn't going to do it, but I guess I am. The square root of 38. Square root of 38. The only factors that divide, the only numbers that are factors of 38 are 2 and 19, which is none of those are perfect squares. So in this case, this one is as simplified as it gets. There's nothing we can do with that one. We just leave it. Okay. In any case, you do have an assignment. Make sure you try the assignment. There's only 5 problems on here. They're on the PowerPoint as well. And watch out for that next assignment coming out on Wednesday, which will be the quadratic formula, which is really exciting. So we'll talk to you soon. Have a great week.